You've all copied that down. Now today, I'm going to introduce a new concept which we have never done before, which is called the angle of inclination. Okay, now before you write anything down, don't copy anything down, I'll tell you what to copy. Now, you need to be aware of what is an angle of inclination. Right? So my past experience, most learners, they just answer questions on grade level analytical on angle of inclination without understanding. Okay, now you need to know that the angle of inclination is an angle between the x-axis and a straight line. And it is measured from the x-axis in an anti-clockwise direction. So if I draw my Cartesian plane like that, and if I draw a straight line, okay, my angle of inclination, there's only one here, which will be that angle there. Okay, and we represent that angle by the Greek letter theta. Okay, the angle of inclination is an angle between the x-axis and the straight line, and it is measured from the x-axis in an anti-clockwise direction, which means this angle is not an angle of inclination. That angle is not an angle of inclination, and this one is also not an angle of inclination. Even that one, or that one, and that one. So an angle of inclination is an angle between the x-axis and a straight line, and it is measured in an anti-clockwise direction. Okay, so I want you to copy down that heading, and then copy down those 3 points, and then sketch that graph there quickly. There is a definition there. Right. A few minutes ago, I explained to you that the angle of inclination is an angle between the x-axis and a straight line. It is measured from the x-axis in an anti-clockwise direction. Alright? So, this angle here, that's an angle of inclination. If we draw a line which is parallel to the x-axis, which is this line here, let me just indicate it in blue, that line there, right? You will find that this angle, which is equal to theta, is going to be equal to that angle there, okay? Because they are corresponding angles from your geometry of straight lines. They will only be equal if this line is parallel to the x-axis. Now, that's a very important concept when you are dealing with questions on angle of inclination. Sometimes you can use construction to create a parallel line which will be parallel to the x-axis. Okay, so this angle and that one are going to be equal because that line which is drawn about the x-axis is parallel to the x-axis. Okay, now let's move on to the formula. Now, before I move on to the formula, I also want you to be aware of the third point here. The angle of inclination, there are two cases. It can be acute, which means between 0 and 90 degrees, or it can be an obtuse angle between 90 and 180 degrees. And the angle of inclination is always positive. Okay? It's never negative. So it must be between 0 and 180 degrees. Okay, let's move on. Now let's move on to the formula. So I want to write that heading. Formula for finding the angle of inclination of a line. Formula for finding the angle of inclination of a line. Formula for finding the angle of inclination of a line. Right? I've introduced that. Okay? So, let's talk about case 1. Case 1. The first case is when the gradient of the straight line is positive. Okay? That's the first case. When the gradient of a straight line is positive. Now, in that case, it looks like this. If you draw a straight line, sorry, the Cartesian plane, like that. Let's say we have that line there, and that angle is going to be angle theta. Okay? Let me label it a different color. Okay, so that's theta. I'm sure you are aware that if a line is slanting to your right, it means the gradient is positive from a grade 9 and 10. If you see any straight line which slants to your right, it means the gradient is positive. Now, when you've got a case like this, if you want to find the angle of inclination, the formula will be tan theta equal to m. Where this m here, you know that m is equal to y2 minus y1 over x2 minus x1. Okay, from your grade 9 and 10. So if you want to find the angle of inclination when the line is a positive gradient, use this formula here. And then if you want to solve here, you end up saying theta is equal to shift tan of m. Like that. That's where you apply your knowledge of trig equations from last year. Okay, but the most important formula is this one. I need to recalibrate. Okay, just give me a second. I need to recalibrate this. Okay, so this is the most important formula. It's tan theta equal to m. Okay, you only use that when the gradient is positive, because shift tan of m, when n is positive, it will give you an acute angle. That is an angle between 0 and 90 degrees. Okay, and when you write examination, this formula is provided, tan theta equal to m. But you need to know when to use it. Okay, so this is the first case. Michael. Huh? Right, I'm moving on to the next page. Okay, those who are in grade 11 now need to learn to write quickly. That's why I don't have to waste time talking about stuff. Right, I need to move on. But case 2. Okay, the second case. Case 2. Case 2 is when the gradient is negative. Okay. Now, when the gradient is negative, you have something like this. You have your straight line like that, and then your angle of inclination will be that. Okay? It's going to be an obtuse angle. Okay? Right? Now, I want you to pay attention carefully because this case is a little bit more complex as compared to the first one. Okay? For this case here, if the gradient is negative, if you use the formula tan theta equal to m to get the angle of inclination, your m will be negative. When you use the knowledge of trig equations here, you get a theta which will be negative, and it will be an acute angle which is negative. Okay? Remember earlier I said the angle of inclination must be a positive angle between 0 and 180 degrees. Okay, to take into account that negative angle, the formula when the gradient is negative becomes theta equal to shift tan of m plus 180 degrees. The reason why we have to add 180 degrees is because this angle here, it is actually an acute angle which is negative. Okay, so if you add 180 to it, you end up getting an obtuse angle that's positive. Now this one here is not provided in examinations. Okay, this formula is not provided. They mainly provide the one for case 1. Okay, which is tan theta equal to m. So you have to memorize it before the examination. Okay, you have to make sure that you know this formula here if you are given a negative gradient. Okay. Okay, so I'm going to do only 2 of them, okay? 1.1 and 1.4. Okay, so let's start with 1.4. Rather 1.1 rather. 1.1. Right, the question says determine the angle of inclination of line AB where the gradient of AB is given. Okay, so you've got 4. These questions are in your textbook. Okay? So, since the gradient is positive, we write tan theta equal to m. It's very important for you to write your formula first. Okay? Then you substitute. We want the angle of inclination, but the gradient is a 2. So theta will be equal to shift tan of 2. Like that. And then you use your calculator. Okay? You use your calculator. So it's shift tan of 2. Okay. The answer to that you get that 63,432 decimal places. So that's 63,43 degrees. It's 2 decimal places. Okay. So it's not difficult, it's very easy. All you just need to know is your gradient positive or is it negative? If it's positive, then you use tan theta equal to m. Okay. Then the second example. That's 1.4. Now 1.4, the gradient is now negative. Since it's negative, we say theta equal to shift tan of m plus 180 degrees. Okay? Our gradient is negative, so that's minus 0.72 plus 180 degrees. So the theta is going to be equal to, I'll use your calculator. Okay, so that's shift tan of 0.72, actually it's negative, so it will be minus 0.72, okay, then you add 180, okay, get 144,25 degrees. Remember, your answers must be in degrees. So the two decimal places should be 144.25 degrees. Okay, so you have the acute case, okay, then the obtuse case. Alright? Okay, let me move on to another example. Alright? Let's move on to another example. Okay. Can you talk to? Right. The second question says, determine the angle of inclination of this line correct to one decimal place. Right, so let's start with 2.1. Okay, 2.1. Now here, you are given the equation. Okay, so from the equation, you must determine the gradient. Okay, I'm sure you remember from your grade 9 that if you are given any equation, you need to make sure that it's written in the form y equal to mx plus c. So for 2.1, it's already written in the form y equal to mx plus c. So that's y equal to mx plus c, which means for that question, m is going to be a half. And that half is a positive half, which means the straight line is slanting to the right. So you use the first equation, which is the main one. Okay, so right here, tan theta equal to m. So your theta is going to be shift tan of a half. Okay, shift tan of a half. Very straightforward. Okay, so that's shift tan of a half. That's 26. Okay, they say to one decimal place, so that will be 26.6 degrees. Okay, right? We are using tan theta equal to m because the gradient is a positive gradient. Okay? Then let's do 2.3. Now 2.3, the equation is written as y plus x equal to 3. It's not written in the form y equal to mx plus c. So I need to rewrite it first. So y plus x is equal to 3. Okay, is equal to 3. This would equal to y equal to minus x plus 3. Therefore, m is going to be negative 1. The gradient is negative 1. Okay, so your angle of inclination, use the second formula, theta equal to shift of minus m plus 180 degrees. So here you get shift tan of minus 1 plus 180 degrees. The good thing is that this gives you minus 45 degrees plus 180 degrees. So your theta is going to be 135 degrees. Okay, this is not 135. I think my board is not calibrated properly because of the wind. Okay, but this angle here, it's 135 degrees. That's 135. Okay, so this is how you approach the question. If you are given the equation, okay, first thing you need to make sure your given equation is in the form y equal to mx plus c. If it's not, then you need to rewrite it in that form. Okay, then you identify your gradient, which is the coefficient of x, and then you simplify. Okay, and when you are doing calculations on angle of inclination, you must get positive angles, no negative angles. And the angles must be between 0 and 180 degrees. Okay, any question? Right, if you don't have any question, then you can do 2.2 as a class exercise quickly. Just write class exercise in your right, 2.2. Okay, so that's 5y plus 2x equal to 10. 5y plus 2x equal to 10. Quickly, it's 5y plus 2x equal to 10. So we need to be writing the form y equal to mx plus c. So that's 5y equal to minus 2x plus 10. You divide each term by 5. So you get y equal to minus 2 over 5x plus 2. So your gradient is minus 2 over 5. Okay? Then your theta will be equal to shift tan of minus 2 over 5 plus 180 degrees. What answer do you get? What answer do you get?
158.
What?
158.2.
158.2 degrees. Okay? Using the graph. Okay? So our lesson stops there for today.